So in this question, you've got 2x minus y, which means that this number must be equal to this number here. So 2x minus y equals 9z minus 5x plus 1. So you can rearrange this to be 2x plus 5x. That would be 7x minus y minus 9z equals 1. So this is equation 1. And you would do that 2 more times. You don't have to do it 4 times, but 3 times is enough because you have 3 variables. I'm going to need 3 equations like that. And then with the 3 equations, we try to start adding equation or subtracting or multiplying by a number, and then trying to get rid of some of the variables like you would normally do with a 2 by 2. But if you want to try that at another time, because it takes more space than is actually on the page actually. So, okay, so look at question 5. So we got Big Bart's Baked Beans Factory produces cans of baked beans. So these are the sizes. So this looks like it's going to be either the row or the column. And it doesn't say what kind of matrix, the way to orientate the numbers. So we got 3 sizes. And we got in February. So now we have week 1, week 2, and week 3 and week 4. So now we have 4 weeks. If you count them, we're going to have 4 weeks. So you're going to have a week number and the size of can. So you've got to kind of go through the question and see what rows and columns are going to be. So we could have size on the top. So let's put the size 200 gram, 300 gram. You can copy this down, and 500 gram. So size, it can go across the top or down the side, doesn't matter, like I told you last week. So this is the week number. All right, so put the weeks in, I'll let you fill it in. So week 1, 2, 3, and 4. 1, 2, 3, 4. So we want to make a matrix just to show the production level in February. So this is all of February. So this is data for February. And so we'll have a square. So don't make a table because you want to make a matrix. Okay, can you spend a couple of minutes to fill that in? So draw that onto your paper. Just fill the numbers in from the question. You don't have to do anything with the numbers, just fill it in. That's it. Okay, so just do that. You'll get, this will be a 4 by 3, won't it? The order. We can write some data down here. Order. It's going to be 4 rows by 3 columns. Remember, it's always row by column. This is just extra information while you're filling that in. So 4 rows and 3 columns. So that's the order. So it's not a square matrix, it's like a rectangle. And the number of elements, that's going to be 4 times 3, which is 12. So 12 numbers in your matrix there. So if you're filling it in, you got week 1. So they go in the same order as is written in the sizes here. So you match it up. So 1,000, 1,500, and 1,250. Okay, so week 2, 1,500, 1,000, 1,000. Like that. Week 3 is here. So it looks like some increase. So 2,800, 2,300, and 1,300. And week 4, 1,200 cans of each in week 4. So 1,200 of each. That's all you need to do. There's no other calculation required here. So just copy that down. And like I said, week can be across the top as well. You could also put week up here, week number, and go 1, 2, 3, 4, and you can put the size down this way as well. So it doesn't actually matter in this question because I didn't specify how you are meant to do it. So either way is correct on the test. Okay, so this is the same idea. You can try that one for practice, but you'll get a worksheet soon anyway, so you'll see it again. Okay, so this next topic is about addition, subtraction, and scalar multiplication. That sounds complicated, but it's not. Okay, we'll see what that is in a minute. So take a look here. Recall that equal matrices have the same number of rows and elements, rows and columns. This is a necessary requirement for two matrices to be added or subtracted. So if you look in question 1 here, just make it a bit bigger. Sorry. Okay, I might have to reduce that if I do any calculations. So where possible. So it may not be possible to add these matrices. If you look at the order, this is a 1 by 3, isn't it? 1 row, 3 columns, but this is 3 rows and 1 column. So that means that you can't add these matrices because the order is different. So cannot be added because, that's because in maths, because the order of the matrices is different. Because when we add them, we need to match the first element to the next one, and you can't match from this one to this one. Okay, you'll have a problem. But this one we can add. You see, we've got a 2 by 2, and this is a 2 by 2. So when you add matrices, you add the corresponding elements. So these two you add these two. We'll do it in a minute. Then we'll add this one, that pair, and then we'll add the purple one, which is hard to read. So then you add that one. So when you do your test or your worksheet, you should actually show that. So -2 plus 9, -7 plus -3, 3 plus 6, and 4 plus 5. So basically you add just the corresponding element, very simple. And if you can add numbers, you can add matrices. You just have to think back to grade 1, don't you? Except some numbers are negative, so you got to think about grade 7 now. So 9 minus 2 is 7. -7 minus 3, -10. 6 plus 3, 9. 4 plus 5, 9, etc. And you do the same here. But this is subtraction. So you would have 12 minus -6, which means the sign is going to change here. -8 minus 7, no problem. So that's going to be 12 plus 6, which is 18. -8 minus 7, that's -15, isn't it? Yeah. And the answers will be shown below down here. -18, 18, -15, let's just check. Okay. Right, example 5. In example 5, we label the matrices as A and B, and it says you want to find A plus B. So all you need to do is basically add your two matrices. So you match them up. So this is matrix A here. This is matrix B, which is this one here. And then you just carry on and do the same as the previous example. So that should be no problem. Sometimes they label it because we don't want to write this out fully here, this part, the A plus B. So it's easier just to give it a name like that. Now your scalar multiplication, which you're probably going to see in physics, you'll see this word scalar as opposed to a vector. So matrices can be also multiplied by a single number. This is your scalar multiplication. So for example, if you have matrix B and A, B, C, D are some numbers in a 2 by 2 matrix, this is your scalar. That's the number we put in front and we multiply to every element. So you can see that K times A, KA, K times B, K times C, K times D. Okay, so the scalar is multiplied just to every element in the matrix. Very simple, okay? It's only when we get to matrix multiplication, which is not done like this. It's quite different. And you'll see soon about that. So in this case, example 6, we want to add X and Y. Well, we have X and Y and we want to do this calculation. So 2 times X, so 2 times the matrix X, which is down here, minus 3 times matrix Y, which is this one here. So now you have a scalar multiplication you need to do. So you've got 2 times -3, -6, like that. And this one, -3 times -3 will become 9. We just got to be careful with this here. Just keep this as positive now. So what I do, yeah, I would just go -3 times -3, 9. -3 times -5, -15, but this stays as positive, right? So just be a little bit careful when you're multiplying this section here. So you should study that a little bit before you do any questions. So be a little bit careful of that. Okay, B is the same, just substitute and multiply through. Any questions? Where are they? So in this question, this is probably an important one, so I should spend a bit of time on it. Now, Suti Rak was actually a student in the school a few years ago. I don't know if you remember him. His nickname was Sun, but his father was like a sold used cars. So I put him in the question right here. So you might see your name come into one of my workbooks in the future if you're unlucky, I guess. So he was a used car salesman. He had 4 cars that he wants to sell quickly. So these are your 4 cars and these are the prices here. Okay, so he's got 4 cars and he wants to sell them quickly. He decides to reduce the price of each car by 25%. Okay, and these are the prices of the cars now. Okay, and we want to convert this table to a matrix and carry out a scalar multiplication to find, that should be TO. So if you find any spelling errors in my book, you can let me know, I'll give you some points. So read through, okay, and look at the examples and the questions too. So you might be able to pick up some points. I didn't notice that till now. So to find the new selling price. So he wants to reduce it by 85%. Okay, if he wanted to reduce it by 50%, he would multiply by 1/2, wouldn't he? So that would halve your score. So if you got 80 on a test and I want to reduce your score by 50%, I'll multiply by 1/2, wouldn't I? And you'll get 40% instead. So if you want to reduce something, we can multiply by a fraction or a decimal, that's 0.5. Okay, but he wants to reduce it by 25%. Okay, so there's a couple of ways to do it, but the easiest way is to multiply this matrix by 0.75. And why 0.75? Because 0.75 would be the new price, because this has already been reduced 25% when I do this. So I think that's the best way. The other way you can do it, you can do your matrix, which is 275. I'll show you the long way. So we'll go, I'm just going to write I'm not going to put the zeros on, 325, 405, and 189. We could subtract 20%, so 25%. So your scalar here will be 0.25. So reduce it by 25%. Then we just write the numbers again. So 275, 325, 405, 189. And that will give you your answer here. All right. You could do that, but wouldn't it be quicker to just multiply the matrix by 0.75? It's the same thing, because this is 1 here. And 1 minus 0.25. So if you actually did some algebra on this, where this is like a common factor, you'd have 0.75. It's the same thing. So, and then you'd go 275, 325, 405, 189. So I think that's quicker, isn't it? So do that instead. But just be careful about your number here. It's 25% reduction. So the new price is going to be 75% of that value. Okay, this is the long way here. What I just showed it here. And this is the short way, shortcut. And on the test, you probably want to do it this way instead. Okay, so this is what I did there. I multiplied everything by 75%, which is equivalent to a 25% reduction. Okay, and add the new numbers in a table. Okay, you can start here. In question 2, you need to show that this is equivalent to this. So you will need to calculate both sides. I can't really ask anything in the item pool today or the chat. I'll just rely on you to do it by yourself, and I'll do a few as we go along. So you need to show this has the same answer, which is an example of the distributive property here. That's the name of the property in maths. So simplify and show they're equal or equivalent as equivalent. So simplify both. So do it on that side too. You'll know if you're correct because you'll get the same answer. Okay. In question 1, to add or subtract 2 matrices, what must be true? All right. You do those 2 for a while. If you're fast, you can go down to here. Okay. So do them. All right. Okay. I'll give you 5 minutes to work on those couple. In question 1, why don't you write in the chat box and you tell me what must be true. So go back to the start of the lesson and think about what I said. So put that in the chat box, that first one. I got one answer. So now I'm seeing if you're paying attention or not. Right, okay. So I got a couple of answers. Yeah, those two are correct that you just sent me, 2 students. Okay, any more? Okay, I only got 2 answers. What do you think? 3 answers? Panovich, same. What do you mean the same? What must be the same? You can clarify that. Same number or same what? But in the meantime, you can do question 2. So in the first one, you must have the same order. So the matrices must have the same order. Okay, if they don't have the same order, you can't add or subtract them. You have to stop. So the order must be the same. So if you have done question 2, why don't you go to 3? There's a few questions there you can do. So in question 2, we need to show that these are equivalent, which means that you need to simplify them. So it's like saying in algebra where you got 3a minus 3b, we could write that as 3a minus b, can't we? The distributive property here. So for matrices, you can actually do the same kind of thing. So if you want to simplify a question like this one, you can change it to this form here. So you need to check. So 3 ones are 3, 9, 3 sevens are 21, 3 fives are 15, minus, it depends on what you want to do here. You can use a minus, but then you've got to be careful when you're multiplying. So let's make it plus. So -3 is 9, -3 times 2, -6, -18, -12. Okay, and then we would add them and then we check that they are the same on this side. So in this case, we subtract the matrices first rather than multiplying. So you're going to have 1 minus -3, which is 4. 3 minus 2, 1. 7 minus 6, 1. 5 minus 4, 1. Like that. And then we'll multiply this. So 12, 3 ones are 3, 3, 3. Something like that. So when we add these on this side, we should get the same answer. So 9 plus 3 is 12. 21 minus 18 is 3. 9 minus 6, 3. 15 minus 12, 3. Good. So you know that you've done it correctly because both of these give the same answer. So if you ever want to simplify a matrix, you can use this property here where A and B are matrices. Okay, so go down, try a couple down here. Do this one. So do this one first. why don't you, so yeah, you can't really put the answer in the chat box, so, and I don't have the answer in front of me, so it'd be end up doing it myself. So you do that one anyway, but make sure you show your steps. So -3 plus -1. So write it all out. Obviously in the test, you wouldn't write all the working, but in homework you should. So many students don't write this. And if you get it wrong, I don't really know what happened. So 7 plus 4, 8 plus -9. So then the next step, 2 plus 2, 4 plus -5. I might go further down in a minute. I might skip down a little bit. So -7 plus 12. All right, then just add the numbers. So that's going to be -4, 11, -1, 2 plus 2 is 4, 4 minus 5, -1. So 12 minus 7, that's 5, isn't it? So that would be your answer. So you should show this working here. You might think you're wasting your time, but not for your score. So it's worth to do this in the homework. In the test, I wouldn't really care because you got to work it out anyway. But your calculator can actually do these. So that's why I prefer to see the working here. This one's the same, decimals. Fraction, no problem. You can do fractions. I'll leave that. So these are your scalar multiplication. So you can go down to 4. What's the time? We finish at 12:20. So we'll see how we get through this topic anyway, because I can get you off a worksheet soon. So scalar multiplication. So multiply your scalar, which is 4, to each number. Okay, so you do that one for a minute. Just multiply it out. All the answers are in the back anyway, so you can always check how you're going. So what we usually never do, or very rarely, we add the numbers that are inside the matrix. Sometimes we have to do that, but usually not. Depends on what we're doing. But so never multiply 3 and 9. That would not mean anything realistically. So avoid doing that. So just multiply out 4 1s are 4, 4 3s are 12, 4 9s 36. So practice this in your head. So 4, 12, 36, pan of it there. That's right. That's the first row. So what you can do is write out these rows. You don't need to put in the chat now. I just want to check you're doing some work or that you at least can follow. So 4 times -5, that's -20. 4 5s are 20. 4 15 is 60. 4 3 -12. 4 5 is 20, -20, -44, something like that. Very simple, isn't it? We're just increasing each element by 4 times by doing that. So imagine we have some products in a shop where we've got cost and number, and we want to increase the number of products we have in our shop, something like that. Oh, here's question 5. You can do this one. These are involving equations now. So what you can do, you can go to the chat and put the answer in for A, B, C, and D. So we want to find A, B, C, and D. So in the chat box, I'll give you a few minutes to do this. So A, B, C, and D. So put those numbers in. Remember, you're trying to match up. So 3A minus 2 is equal to the corresponding element here. So that will find you A. You can do that one, and you can do the rest now. So 3A minus 2 equals 20. So always match the corresponding elements, the matching elements. All right, so you calculate A, B, C, and D and put in the chat box. So just basic maths and algebra you're doing here. It gets more complicated, but this is okay for the first couple of lessons. Okay, anyone got A, B, C, D? They're just equations and you solve them. Oh, I got 2 answers. So who else? Yeah, you might end up with fractions and stuff. So if you have answered, you can go to the answer key and take a look and see if you did it okay. So A would be 3A equals 22. So A is 22 on 3. So that should be your first answer, or you can make a decimal as well. What about B? 4 minus 2B equals 12. So 4 minus 2B equals 12. Minus 2B equals 8. B is minus 4. Yep, 8, 12 divided by negative 2. Negative 4 there. Let me know if you see anything wrong. What about C? Negative 7 minus C. Negative 7 minus C equals 18. So C would be negative 7 minus 18, wouldn't it, when I swap these around? So 8, negative 25, right? Like that there. What about D? The last one, we've got D, which is here. So it would be 2 minus 6 equals D. Oh, it's negative 4. All right. Right here. So D would be negative 4 for that one. So just a simple equation problem. How about this one? Find the matrix X. So you won't, I don't think you'll be able to put that into my chat box, but if you want to, you can do row 1 first and write the numbers in row 1. There should be 2 numbers here. And row 2, the second row. You can write it like that if you want. But this is a matrix. So what you've got actually is like A, B, C, D. This is X. So think about what you're going to do here to find these numbers. I think you can put this on the other side. Here, try that. So that one you have to think about. The answer is a matrix, not the actual element, but there are 4 elements you need to find, like A, B, C, D. Okay, see if you can do that one. What else is here? Whoops. Yeah, a little bit of, I can show you more of that. I think we're going to have another period on this topic anyway, so we'll do some more tomorrow. Or not tomorrow, next week. Okay. Okay, try do that one. Yeah, so in the chat box, you can put it in this order here. So, or actually you can call it A, B, C, D. Why don't you do that? That might be easier. So A, B, C, and D. I've called them A, B, C, D here. But I would move this part to the other side, and you can do that. You can move matrices around. Adding and subtracting is no problem. Dividing, you can't though. Dividing, multiplying have special rules. So just stick that on the other side. So you would have X is 2, 5, 7, -6, plus, so I've got one answer already. All right, so you carry out that calculation and then you'll get your answer. Because that X is this here. And I don't have the answer on me, so you'll need to look in your answer key. I won't be able to tell you if you're right. Okay, Panavit. Let's see in a minute.
Wait, sir.
Yeah, it's okay. You just double check the working. You can write it as A, B, C, D. Just do it like that. Okay, one answer. We'll run out of time soon, but we got tomorrow anyway. Nipa. Is that correct? I don't know either. I'm going to check in a minute. So just check your calculation here. Multiply first and then add this number. So we'll do that here in a minute. If you finish, go to the next question and take a look. See if you can work out how to do it. Your first worksheet would have the introduction section plus this topic when you get your next worksheet. So I'd like to finish up as much as I can. You can always search on the internet, adding and subtracting matrices. You will find lots, thousands of videos about it. Sunita, so let's. Pat, you sure? Want to take a look? So we've got 2 times -2, -4, -3. So don't multiply the 2 to this here. So the 2 is only multiplied to the first one. You see, it's not in bracket, is it? Okay, so the 2 is only multiplied to that matrix. So do that, not to the second one though, because it's not in brackets. So if it was in bracket, these matrices, okay, you can expand it that way, but not this one. So 2 times -2, -4, minus 3. And we'll have 2 times -5, -10, plus 7. 2 times 7, 14, plus 0. 2 times -6, -12, plus 8. So don't stop there. So -4 minus 3, -7. -10 plus 7, -3. 14 plus 0, 14. 8 minus 12, well, -12 plus 8, that's -4, isn't it? So practice doing it in your head, your basic calculations. So we got that answer all right? Okay, so yeah, if you had a bracket around these two matrices, then you can multiply the 2 into both. But not here, it's only 2 times that one, because this one was brought to the other side. All right, we've got 5 minutes left. Now, take a look at this one. We've got 4 times the matrix. Okay, it'll be a 3 by 2 as well, because it needs to be the same order as what's given. So we know it's a 3 by 2 matrix because it must be the same as these ones here. So X is a 3 by 2. Now, you could put your 4 times X. It's going to be a little bit complicated. So what you do, just try to treat this like an equation. So 4x equals B. Now bring your matrix A over, just like you would do in algebra. So minus A. Okay. Now this is a scalar 4. So what we can do, we can divide both sides by 4. Well, actually what I'll do, instead of dividing by 4, let's multiply by a quarter, which is more accurate. And so this will be multiplied by a quarter here. So this would be your scalar. And then this, cancel that. So then that would be your answer. Well, not your answer yet, but you need to finish it. So you're going to have your matrix, which is X. You can do this yourself now. So do this as your final question. It's a quarter multiplied by the matrix B minus A. I'll just keep it as matrix B minus matrix A. So you should do this subtraction first, or you would need to expand a quarter as a scalar. But what I recommend, do this calculation first, get a matrix, and then multiply each element by a quarter. And that will be your answer. Okay, so you can finish that one. Okay, so try that one. So we just use a little bit of algebra to rearrange things. Okay, we just can't divide a matrix by another matrix. We have to do other methods to do that. We can multiply matrices, but it's not the same as adding, right, or subtracting. Right, so do that calculation. There's only a few minutes left. So B minus A, and then multiply each element by a quarter. You'll get 6 elements because it must be a 3 by 2. So I'll do a little bit of work. You can finish it because time's nearly up. So it's a quarter, B minus A. So you got 4 minus 3. So go back in the other direction because it's B minus A. So 4 minus 3 is 1. 0 minus -3 would be 3. 0 minus -8 would be 8. -5 minus 0, -5. 3 minus 4, -1. -1 plus 1 will be 0. Okay, so this is your B minus A matrix. So we've got a matrix here. So your final answer will be multiplying each element by a quarter. So 1 times a quarter is a quarter. 3 times a quarter, 3/4. We'll have 8 on 4, which is 2, minus 5 on 4, just multiplying now, minus a quarter. 0 times a quarter is 0. So hopefully that's the answer in the back of the book. All right, I think we'll stop there. So just check you can do that. So we've learned a few things today. Comment, Sunita. Yeah, did you get the same as me? Something like that. Yeah, looks the same. So that's your answer there. So when you come to question 8, I think we might do some tomorrow because we only have 1 minute left. But we want to find matrix Q, this matrix. So let's do a bit of algebra to rearrange it. Well, you've got a 3 here, which is a scalar. So tomorrow or the next period, which will probably be next week, we'd multiply both sides by the scalar 1/3, like that. So Q, and that will cancel. So Q will be 1/3 times R minus 2P. And these are your matrices here, R and P. So R minus 2P. So you'd have to do this calculation. This in green first, and then multiply by 1/3 to each element, whatever the elements are. And you can think about how would you rearrange this one. We want Q. O is a null matrix, a 0 matrix, by the way, if you forgot that. That's a 0 matrix. And so it's going to be the same. So actually, we'll do this later, but this would be your null matrix. So it's going to have to be the same order, otherwise you can't calculate. There, we can add that on for this one here. So we might continue with that on the next period. Let's see. Oh yeah, we got some word problem, couple of things to do. Yeah, it's probably going to take another period, this topic, which you may get the worksheet a little bit early, but you can start it anyway for some things. All right, so let's stop there. And I'll post this onto the YouTube a little bit later, okay? So I'll talk to you later then, all right? Okay, bye-bye. And I hope to get your worksheet
Bye, Paul.
today, right?
Thank you,
Yeah. Okay, see you later.